You guys built your ACL, so looking at the problems here, let's see. Oops, previous. What standard ACL can we build to build block packets from 172.16.5.4? Okay. So we can go permit 172.16.5.4, allowing those packets. So the whole command would be IP access dash list 1 permit and because we're a standard access list, the only thing we can do is source address, right? Okay. Come on. What about our second one? Packets from host with 192.168.6 as their first 3 octets. So again, IP access dash list permit 192.168.6.0 and then the inverse mask 0.0.0.255. That's correct. How about from hosts with 192.168 as the first 2 octets, allowing any of the third octets? Chris has got it again. 192.168.0.0.0.255.255. From any host. Permit any. How about packets from subnet 10.1.200.0/21? Okay, so we figured out what the mask is. 21 is to 48. So we subtract 256, subtract 248, get 7, 0.007, 255. So Chris, you are correct. How about the next one? 10.1.200.0/27. Okay, so we got 0.0.031. Next one is a /23. What's the inverse mask of a /23? And 1.255 is correct because we're stealing just 1 bit from there. So that is correct. Stealing 1 bit back. Next one is 0/26. So we're two more bits. So 192, 255 minus 192, 63, 248. Yep. So 240 is the mask, and inverse of that, 255 minus 240 is 15, so 0, 0, 0, 15. And our last one, 30. And Chris, you are correct again, that is 3, 0, 0, 0, 3, because our mask is 252, so 255 minus 252 is 3, and we put in the 3. Nice job, Chris. Is everyone else all set with those? You got to remember when you're using masks in the ACL, it's inverse masks. Very important. So here's the math to do that. So finding IP addresses and ranges that match by existing ACL. So we have this ACL, or these ACLs, access list 1 permit 10765. What matches that ACL? Is it a range of addresses? Is it one address? Is it no addresses? Chris, again, just that address, right? So if we don't have a subnet mask, it assumes that this is a host, and it has to match exactly. So it will have to be just that host. So on the next one, we have 192.168.40.000.127. What is the subnet mask of the subnet that would match? So we can use the same process to get back that we used to get here, right? We take 255 and minus 127, it gives us 128. So 255, 255, 255, 128 would be the mask for the addresses. And then we could figure out the range from the mask, right? Like we were doing previously. So in this case, it would be 4.1 to 4.127 or 126. Yeah, 127, 0 to 127, so it would be 1. The actual addresses would be 1 to 126. Because we have to take off the network ID and the broadcast ID. So the next one, 00031. What's the mask? $224, so 255 minus 31 is 224. So 255, 255, 255, 224. And what's our increment with 224? 32. So we know we can go from 6.0 to 6.31. So 1 to 30 are our valid numbers, 192.168, right? Let's just do a couple more. Let's do this next one because it's a little bit different. And then we'll skip down and do number 8. So we have 3.255 in our 172.30.96. So what is the subnet mask? .252.0. And what is the range of addresses? What's our increment? Yep, correct, Chris. 96.0 or .1 would be the first address, and then 99.254 is the last because if this goes to 100, we're on a different network. We already have our increment. We just add 1 to this, and that's our increment in this octet, right? So let's jump down to the last one. 10.192.0.0063.255. So what is our subnet mask? .192.0 because we take 255 minus 63, that gives us 192, and the 255 becomes 0 because we take 255 and minus 255, so 0. So what is the range of addresses in the 10.1.192.0 network? Yep, 10.1.192.1 to 10.1.255.254. Because we're incrementing by 64, we're at 192 already, so 256. Can't go to 256, so down 1 to 255 is our last, and 254 would be the last usable host. See all that subnetting stuff we learned a couple days ago? Coming in handy. So we have this example, and I want to point out that if you put in an address and you put in a mask, it is going to, when you show the access list, show you the appropriate network associated with it. So if you put in this 10.1.1.0.0.0.255.255 and then do a show IP access list, it's going to show up as 10.1.0.0.0.255.255 because that's the network identifier for that set of wildcard bits. So if you meant to only do this one address and you put in this inverse mask, you're going to block that whole subnet, or in this case, permit that whole subnet, 10.1.0.0, 10.1 anything. So be aware that that does happen, or can happen. Any questions on that? So seldom will I use a standard access list because you're limited to only source addresses at that point. I can't do anything with ports. I can't do anything with destination IPs. So normally I am actually going to create an extended or enhanced ACLs. So we're going to take a look at the extended ACLs and what we can do here. Far more robust. These go from 101, number 101 on up, or I can name them and use named access lists. So it allows me to use protocol type, so TCP UDP, allows me to use source and destination. It allows me to use TCP, UDP headers, so information from the header, like ports, for example, as well as other protocols, EIGRP, IGMP, OSPF. We have the additional information that we can also use. So here's what it looks like using the numbers. Access list 101. No, it's 100 to 199, and then 2000 to 2699. Why that is, I don't know, but it is. And then it's permit what protocol, IP, TCP, UDP, ICMP, EIGRP, whatever protocol you so choose in here. Could also do something like HTTP or FTP. If you do TCP or UDP, you then have source IP and port, destination IP and port. If I choose IP, then I just have source IP and destination IP. So here is a couple of commands to take a look at. Access list 101, we know it's extended because it's above 100 to 199. We are doing a deny TCP any. So if it's a UDP packet, in this first example, it would be allowed. If it's a TCP packet, it's not going to be allowed. Likewise with the second one, UDP. If it has a UDP header, the IP packet will be dropped. ICMP, if it has an ICMP header, it's going to be dropped. Deny IP host 1111 to host 2222. This is how I specify a single address. I put in the host keyword. In this case, it's going to deny any traffic from 1111 to 2222. And the next one is deny UDP 11110 00255, just like we did before for the source, except we are putting the network range, right, and the inverse mask, and then any in the destination. Now I also could put another network in the destination, or I could put an individual address, or I could put a host in the destination. So I have flexibility as far as how I deal with that. So this is just showing you that the protocol is identified in the IP header. And if you specify TCP, then it will look to the TCP header and actually look into the TCP source and destination ports. And you can block by those as well. So when I do that, I have protocol TCP or UDP, and then I can do the source IP, and then the port. So equals is EQ is equals, so that would be an exact port. I have not equal to, NE, less than, greater than, or a range. And then I can put in a range of ports. And I have the same thing after the destination IP, I can put in a range of ports as well. So here's an example. We are permitting TCP from 172.16.10.0000255, so anything in this subnet, to anything in this subnet that equals 21. So that's TCP port 21 on the destination. So that's FTP. We're allowing anything from 172.16.1 to 172.16.3. That's FTP. And that could be applied as an inbound filter here, an outbound filter there, an inbound filter there, and an outbound filter there. We can also filter packets based on the source port. So now we're working the other direction because source is coming from over here, 172.16.3.0. TCP equals 21 to the destination anywhere over here. I could also combine source and destination, but you probably don't want to do that. Because usually when you're talking to a particular source, your destination port is random. Or your source port is random to that destination. There's rare exceptions, like FTP is one of those exceptions, where it uses 21 either way. So here are some of the standard ports. You also have keywords you can use. So I could do TCP, EQ, FTP data, or FTP, or Telnet, or SMTP. So I do have some keywords that are built into iOS. Port 80, www, TFTP is port 69, POP3, SNMP. Note there's not one for SSL, syslog, RTP. There's no keyword for that. You just have to use the port. So here's some examples. In this case, we have access list 101. We're denying TCP any. So what's this? What's this any indicate? Any what? Source IP. Yeah, so it's the source. We always put the source first. So we're denying TCP to any, from any source. What's GT? Greater than, in this case, 49.151. So any port greater than, TCP port greater than 49.141 to host 10.1.1.1. What's this host? The destination, yep, equals 23. So from any host, TCP greater than 49.151 that's trying to talk to 10.1.1.1, the host, on port 23, the destination port. So note we have a source port or a range of ports. We have a source IP. We have a destination IP and a destination port. Now, I don't have to have all those. I can mix and match. So I could just have the host without this EQ's 23. I could also have this any without the GT 49.151. So for example, we have a deny TCP any host 10.1.1.1 equals 23. So I don't have that source TCP port, only the destination. And I've accessed this 101 deny TCP any host 10.1.1.1 equals telnet. Same thing, port 23 is telnet, but I can use the keyword because that's one of the defined keywords. And here, access list 101 deny UDP 1000 0 255.255.255. What's LT? Less than, yep, less than 1023. So any TCP or UDP port less than 1023 source from the one anything network to any host. So it's just showing you access list, showing you the format. So in this example, we are trying to stop Bob from getting to the FTP servers and Larry to server web. So we're trying to stop Bob from getting to the FTP and Larry from getting to the web server. So our command to do that, and note, we could apply this here, inbound, here outbound, here inbound, here outbound. But if we wanted to make this just one ACL, the best bet is to go to R1 and provide it here outbound, because then we can capture both Larry and Bob in one access list. So here is the interface, the serial 0, serial 1. So they're actually doing it on the inbound here, serial 0, serial 1, using the 101 access list inbound. And we're denying TCP host 172.16.3.10 to 172.16.1.0.0.0.255 equals FTP. Any FTP on that subnet. And then for the other one, we're doing deny TCP host 172.16.2.10 to the host 172.16.1.100. So host to host equals web. We don't want him to pass any web HTTP or port 80 TCP traffic as the destination. And then we permit IP any. If we don't permit IP any, what happens? If I don't have this at the end of my access list, what happens to all the other traffic? Yeah, it's blocked because there's an implicit deny at the end of every access list. So there's actually a deny IP any after this. Now I've permitted it so it would be allowed, but it's an implicit deny at the end. So this is now looking at R3's access list to stop Bob. I obviously can't stop Larry because Larry's up here, but I could stop Bob. Right? So here I can only stop Bob. So same thing. I'm still denying, right? I'm denying the same host from talking to anything FTP, except now I'm on this device and my inbound interface is Ethernet 0. Sorry. Back here, Ethernet 0. I'm putting that as an inbound ACL to stop Bob's traffic from ever getting out into the serial network. And where I put that will really depend on my network and how I want to manage it. From an efficiency perspective, it's best to put it here, but from a management perspective, it may be best to put it here because then I can just build one access list as opposed to building multiple and try to manage each of them. So in this case, we have access group 110 in, so it's an inbound ACL. We're denying IP host 10.1.2.1 from talking to anything on 10.1.1.0. We're also denying 10.1.2 network from talking to 10.1.3 network. On interface Ethernet 0. So we're blocking that host and that subnet from talking to two different things. All right, so let's see here. We'll go back to that in just a second. We also can do these as named ACLs as opposed to numbered. And the only difference is it gets a name as opposed to a number. So these are access list 1 permit. This is going to be IP access list, either standard or extended, and then the name, and then it's just like the regular access list. So here's an example of a named extended access list. I have an IP access list, extended, Barney. I have a permit statement. I have a deny. I have a deny. I have a deny. I have a permit. Notice there's no numbers on these. But really there is numbers on these. It, by default, does them 10 apart. So it does 10, 20, 30, 40, 50. That allows me to go back and add entries if I need to. And I also can renumber them. When I do access lists now, I only ever use named access lists because it's much easier to identify what the purpose is. I can have a description on an access list too, but it's easier just to use one kind, and this works for everything. The other thing that I can do is I can remove one command from that named ACL by doing a no. So I'll go into the access list, extended Barney, and then do a no on that one line. And then when I show that access list, that line is gone. And note they are numbered 10, 20, 30. Note 40 is missing because that was 40, now 50. So I can insert, as I told you before, if I create a list, it does it by increments of 10, 10, 20, 30. I can go in and remove by number, so I could do a no 20 on the list. I can also insert by number. So in this case, I'm putting a 5, deny 10, 1, 1, 1. That's going to put it as the first entry in the list. So it allows me to change the list without having to completely rebuild it, which if it was a numbered access list, I'd have to completely rebuild it. So here's an example of adding to and displaying a numbered ACL. Show run shows me the access list. Adding a new access list 24 global command, so config T, access list 24 permit 1011, is just going to add to the end, right? So that I can add entries to the end in doing so. If I want to add an entry in the middle, I have numbering, so I can do the same thing. I could do a, like they did here, 5, deny, and it puts it in the numbered list as well. That's new. You didn't used to be able to do that with numbered lists. So general recommendations. Place the extended ACLs as close as possible to the source of the packet. And the reason for that is you don't want the packets on the network that are taking up bandwidth when they don't need to. So you want it as close to the source as possible. Place standard ACLs as close as possible to the destination of the packet. And the reason for that is because you don't want something getting around coming from a different place. You want it to be blocked at the nearest router, basically, to the destination. Place more specific statements early in the ACL, because remember, it does a top-down analysis. So if you wanted to be a particular address to be blocked, that's got to be above a generic permit of the subnet, because the permit of the subnet would take and that block would be ignored. Disable an ACL from its interface using the no IP access groups interface command before making changes to the ACL. I don't know how many times I've seen people go in and modify an ACL and mess it up by doing like a deny any, and then they lose access and can't do anything because they left it on the interface. Take it off the interface, make your changes, validate it, put it back on the interface. Any questions on that?